You're listening to Blue Collar White Coat Podcast, the only podcast telling the real stories behind the people powering science. Hey everyone, and welcome back to Blue Collar White Coat. I'm really excited about this episode because today I finally get to bring you our first true blue collar guest, someone whose hands, skills, and problem solving literally keeps science running behind the scenes. This is the second to last episode of season 1. That's bonkers. That's just crazy to me. This whole thing has felt like a fever dream. It came to me as an idea in May, and here we are at the second to last episode. So I'm really excited about this conversation today because it's kind of a perfect tee-up of what I want season 2 to be and what I'm starting to lay the groundwork for. I'll get more into it in the next episode. I don't want to get too ahead of myself, but next season is definitely going to focus more heavily on the skilled trades and the blue collar work like electricians, fabricators, operators, technicians, machinists, like my guest today, Kyle. I've got a lot of ideas cooking for season 2, and I'm planning on doing a lot more video content. So make sure you're subscribed to our YouTube channel and following us on Instagram and TikTok at Blue Collar White Coat Pod, all one word. And you want to get in there now because we're going to be posting content from this season, including some conversations and some interviews that didn't make it into final episode format. One including my friend Anna, who went from literally working at strip clubs to being a marine engineer, designing ships, icebreakers. No big deal. So once again, come find us on YouTube, get in there at Instagram and TikTok too. Don't want to miss it. So sign up, follow us, subscribe, do all those things. Hit all the buttons, as they say. So on today's episode, you're going to meet Kyle Luker. He's a machinist. I guess we didn't really define what a machinist is. So basically a machinist is anybody who works with metal in different ways, whether it's creating parts out of sheet metal or shaping metal with different tools we're going to talk about called mills and lathes, bonding metal together using welding, creating parts for other machines that make parts. It's crazy. Machinists are really, really skilled workers and they can do a wide range of different things. So Kyle is really special because he's kind of self-taught in a lot of ways, and now he's working for a major university as the manager of their research and development, or R&D machine shop. But he started out of high school in a much different field, firefighting. So I'm really excited for you to hear him tell his story about how he made that transition and how he built his career out of kind of just figuring it out and what he says pivoting and learning to roll with punches and setbacks and changes. His story is exactly the kind of human, hands-on, messy path that I love highlighting on this show, and I hope that whether you're listening to this episode in a lab or a workshop, you come away having a new appreciation for folks like him. And hey, before we jump in, if you're enjoying these stories about the people who make science work, don't forget to leave us a review. I know I'm annoying, but as I've said before, reviews are the #1 way to help new shows like this one reach wider audiences and hopefully more people who may not see themselves in STEM. Not yet, anyway. It's especially important going into season 2 to get feedback from all of you and to get the word out about the show. So thank you if you have given us a review. That's my soapbox moment. Okay, let's get into it. Here's my conversation with Kyle Luker, R&D Machinist. Welcome, Kyle Luker. I'm so excited to have you as kind of my first ambassador of the blue collar end of the spectrum. And thanks for being here on Blue Collar White Coat.
Glad to be here.
So a little background here. We don't have much. As I was starting to kind of collect information on doing this podcast, I wasn't sure exactly, who my audience was going to be. I wasn't sure where to look for different resources. If you follow NASA online, if you follow any engineering school online, you see tons of video and content about this is the satellite we're building right now. And you see all the folks in their Tyvek and they're what they call them, bunny suits in the clean room. but they're not talking about who those people are or what their training is or anything. So I guess I was on this mission to kind of explore that and find out where I would find people like you.
Yeah.
And I ended up on a subreddit, and I think I was just putting out questions like, does anybody have this kind of job? And sure enough, you and a few folks actually pinged in and were like, hey, me. So you and I decided to chat a little bit to kind of like, strangers on the internet, get a feel for one another. And yeah, I guess the rest is history. It's been like a couple months, but that's it.
Yeah.
So yeah, that's awesome.
That sounds about right.
Yeah, right. Okay. So tell us, what's your job title now? Like, what do you do? And give us a sense of where you are professionally.
So I'm a machine shop manager for a large academic research institution, and I'm basically a one-man band. I'm the only one in my machine shop. I do woodworking, plastics, repair work, CNC machining, welding, modifications to equipment. It just depends what comes through the door. I kind of say yes to everything. I have one direct supervisor. And when I got hired, she said, hey, I have no idea what you do. Just give me billable hours. So it's a dream job. Like
Yeah.
I work by myself. I play nicely with myself. I don't necessarily always play well with others. So that way, when I get to a machine and it's messy, it's like, oh, who left this mess? Oh, that'd be me.
Oh, right. Yeah. So, wow, I didn't even know that you
Yep.
did like woodworking and stuff like that too. That's
Yeah,
amazing.
I kind of have to be the jack of all trades. Like I said, I do it all, and even at my house, I have a full wood shop and a full machine and weld shop. I just like building stuff. It's funny because growing up, I didn't do any of that. So
Really? So, like,
yeah.
we talked a little bit about your background, but I think we mostly talked professionally. So, like, tell me about growing up.
Uh, grew up down in LA, and yeah, mom was a computer programmer, dad was in the movie industry. I was into photography, and I guess we'll lead this into kind of my career start, as it were.
Yeah.
Basically, in high school, junior year, all my friends were applying off to 4 years, and I was like, I have no clue what I want to do. I was on the wrestling team. One of my good buddies who graduated a year or two ahead of me came back and said, hey, I know you like to backpack and camp. I'm on this Wildland fire crew. You get to play with fire and chainsaws and camp in the backcountry. And I was like, sounds cool. So I was like, you know what? Firefighting seems like a good thing. It seems like a good way to get back to the community. That was junior year. 2001 senior year, 9/11 happens,
Yep.
and it was kind of like, you know what, this is something I want to do. So I started going to school, got my associate's degree in fire technology. I spent 3 seasons on a fire crew down on the Angeles National Forest. And from there, I went through a fire academy, got hired by a different department. I spent 5.5 years on that crew. And this was around 2008 was when the financial crisis first happened.
Mm-hmm. Oh, yes.
And it working for governments, it takes time for these things to catch up. So I think it was June of 2011, I ended up getting laid off due to budget cuts. Prior to that, while on that fire crew, I worked with the bulldozers and heavy equipment
Hmm.
with our department, and they taught me the basics of welding. And I had
Hmm.
never welded before. I'd never built much with my hands other than like
Yeah.
fireline. And so I really enjoyed the welding. And one day I had kind of seen the writing on the wall that budget cuts were going to be
Sure.
coming and maybe I should have a backup plan. And I also had a bad back at the time. Like I got
Right.
2 herniated discs in my back, and that was kind of the sign of like, you know what, no department is. I'll pass an interview, I'll get to medical, and then I'll be told, oh, thank you, sorry, bye bye. So I need to figure out some sort of backup plan. And randomly one day there was this 100-year-old blacksmith building in town. One day my girlfriend and I, now wife, were walking downtown, and I see the doors open, and I see this guy welding up a railing on the ground. I was like, hey, like I already have a job, but like I'd love to learn more. So I talked to the guy, and he's like, kind of blows me off, says, come back in a month, talk to my brother. Okay. So a month to the day, I go back and talk to the brother, and he's like, well, I can't pay you right now, but
Right.
yeah, if you want to come help out, sure. So I helped out for a couple months, and then they started paying me for my time. And then when the new budget came out, I think it was June of 2011.
Mm.
The crew I was on got disbanded, and they picked me up full time. And I ended up working for that blacksmith shop for, I think it was like just shy of 6 years, or right around 6 years. I learned a lot. Basically, we had to be high-end finished carpenters. We're doing a lot of custom railings, doors, gates, signs.
Mm.
Um, and this was full hammer and anvil, blacksmith and welding. It was fun. So during that time at the shop, I eventually became their shop foreman and their precision guy. I had to teach myself TIG welding and machining. The shop ended up eventually getting a mill and a lathe, and they said, "Here, we got these. You figure it out."
Wow.
So YouTube University was kind of how I learned all that. The amount of knowledge that's on YouTube is
It's
indispensable.
wild. Hmm.
Yeah, since the shop was kind of starting up at the time, like they'd only been around like a year or two when I started working for them. We were at a point where we couldn't say no to jobs. So
Mm.
someone would come in and say, "Hey, can you do this job?" And we'll be like, "Oh yeah, totally, we can get that." They'd leave, and we'd be like, "How do we do that one? Like, we better figure that one out."
Oh no.
So it was really good in the sense that it pushed me out of my comfort zone and
Hmm.
forced me to learn new aspects. And I've in my professional career, I've always been like, I just want to learn more. Like, I want to
Yeah.
do more. I want to expand my capabilities and make cool stuff. And the more I know, the cooler the stuff I can make.
Yeah.
Uh, so I worked for them for about 6 years, and it got to the point where I kind of learned all that I could from them. I think eventually I ended up finding another job. I left on good terms. They do awesome work. So then I got hired as welder machinist for a clean coal and concrete technology company. I worked for them for 2 years. They sent me all over the world. I spent a lot of time on the East Coast, spent time in China, spent time in Oregon, learned a lot. And the amount of travel they were having me do was
Yeah.
just
It's a
a
lot.
ton.
Brutal.
In a 1 year period, I was gone for 9 months, and I had a 2 year
Mm.
old at home. So
Yeah.
started looking for a new job, found a job at a large skateboard manufacturer as their R&D machinist, welder, fabricator, and eventually became their, once again, jack of all trades.
Yeah.
I do heavy equipment operation. I've done rigging. So I was
Yeah.
able to take those skills and apply them at the skateboard manufacturer. And our big thing there was automation. They've been around for quite a few years. All the machines were made in house because
Mm.
you can't go to a manufacturer and be like, "Hey, I need a skateboard making machine," and they'll be like, "Good luck." So we made all our presses we made in house, all the wheel molds. We would make tens of thousands of wheel molds on our CNC lathes. And like some of those molds are like, there are people pouring the same molds for the last 20 years. There's a lot of work that goes into making just the toys that people like.
I was just gonna say, you don't think about even I don't even think pro skateboarders have an appreciation for like you said, there's no Acme instant skateboard machine just stamping out skateboards, right?
Well,
Or the trucks or whatever. But also you have to like stress test, like use the right
yep.
kinds of metals to so that when someone's landing on them over and over again or grinding or doing, I'm not gonna pretend I know anything about skateboarding.
I did work closely with the guy who was in charge of our destructive testing, so that was always
Mm-hmm.
fun. We had
Mm-hmm.
a couple machines that were meant for breaking bearings, breaking trucks, breaking wheels,
Yep.
breaking decks. So
Because you got to break
all
it
that
to know how to make it not break, right? That's so
exactly how to
cool.
make it stronger. And so one of the other big things was automating all this old equipment, making it so that it's safer, it's automated, and just more efficient. Like one of the fun ones I got to make were a couple of these grip tape machines where we would
Mm.
have this roll of grip tape, like several hundred feet of sandpaper on stickum, and we made a machine that would automatically feed it out to a set length and cut it to size. So it was just making stuff like that from scratch was a ton of fun. I was happy there. Had been there, I think, a little over 3 years, and then the machine shop manager who I worked with told me about this job at this large academic research institution. He's like, "Hey, there's this job. I'd apply for it, but I can't do the welding. I know you'll figure out the CNC work. Because at the time I'd been a button pusher. I pushed the green button, loaded the material, but I'd never done any of the programming setup
Mm.
or the designing. But then he was like, you'll figure that stuff out. So I applied for the job, and they liked what I had to say. And
Yeah.
then I got the job, and this was at the tail end of COVID. I got hired, and it was to the point where the first like couple months, I didn't really have people coming into the shop. I had a couple things here and there I would do annually on the mills and lathes that were in the shop, but I poured myself into at the time. LinkedIn Learning has some
Mm.
really good courses on
Yeah.
SolidWorks and HSM for programming. So I was able to really train myself.
Yeah.
And the first project I gave myself was my name tag for my door. A real simple part, not a lot of heavy machining,
Sure.
but I needed to program it. So I designed the part, drew it up, programmed it, and the end mill I had to use was a 20 thou end mill, which for that'd be half a millimeter for the metric people, or think of it as maybe 5 sheets of paper.
Yeah.
That's how thick the end mill was. It's 5 sheets of
Wow.
paper. And my thought was, if I can do this and not destroy the tool or the machine, I can do this. Because at the time, I was having some major imposter syndrome,
Yeah. Yeah.
and those feelings have mostly subsided.
Y-
They rear up every now and then,
Yeah.
but
Yeah.
so I had this itty bitty end mill that I had to machine my name in, and it was one of those. I programmed it. I do it. I go slow, watch the tool come down, floods with coolant, and it's like, okay, well, here goes nothing. So let it run, blow the part off. I have my name on this plaque. It's like, all right, I can
Did it.
figure this out.
Yeah.
And that was kind of how I got my start at this research institution. So
That's amazing. Yeah, so we're gonna go back and dig into some of the details on each of these incredible, experiences that you've had, and I don't know, like you were kind of set up for this. I feel like your genes were ready for this because you had a computer scientist in your family, and then you had someone in the film industry, and
Mhm.
maybe he was an accountant or something, but I get the sense that if you're in the film industry, like you have to be somewhat of a MacGyver. Like, oh, the weather's doing this, so we have to do this now with the camera, the lighting, or
Yeah, but it was one of those I had never really made anything with my hands. Like
right?
and for me it was that those first experiences learning how to MIG weld, where it's a wire feed. I describe MIG welding as the hot glue gun for me. It's, if I'm gonna teach someone and they just want to make some stuff around the house, like weld up a gate on their yard, I try to teach them this because it
Right.
is the simplest.
Was
It
that
is
the
the
first you learned?
Yes. So MIG welding, it's literally you put your ground clamp on the material, we turn on the gas, you set your voltage and wire speed, and you pull a trigger. And
Right.
it's you just kind of go, you weld out. And yeah, my first welds weren't all that anything to write home about, but I
Because that's like
saw
a thing, right? That's like when you're leaving your mark, like so people can see what
yes.
your welds look like. And I know like the thing I learned about was like, oh, it's a roll of dimes or whatever. That's what you're aiming for. And I guess maybe for listeners that have no idea what we're talking about, next time you see like a gate or a piece of machinery or any like maybe like stainless steel kitchens or whatever, look for that seam, and
Yep.
you'll notice that it looks like he said hot, like silver hot glue that was then, either smoothed
Yep.
over, but in this case it's not. It's just the skill of the welder.
Yeah, I learned the basics of metalworking, like using a drill press and cutting oil when you're drilling on metal. And it it was one of those, like, you feel like a wizard where it's like, I am joining this metal and it's going to be strong, like.
Yeah.
And I learned a good saying of nothing too strong ever broke, or
Mm.
nothing is engineered like over engineered. Like I like building stuff that's not gonna break. I just like building, and the welding was really the one thing that really sparked that. Like,
Like,
I want to start.
unlocked.
Yeah, it's like I want to start making stuff,
Yeah.
and I tell people now, like I do give welding lessons where I'm at, and I tell
Cool.
people, like, if I had to choose between welding and machining, I would choose welding because
Yeah.
I just enjoy it. Like TIG welding to me on stainless, it is so cathartic and so relaxing, and I just
Yeah.
really enjoy it.
Well,
So
and, like, they so much of and this is not to take away from machining as a
mhm,
trade at all, but so much of it is automated now with these huge machines that you can put a
yep.
whole thing in, and by whole thing, I mean anything from, like, a spaceship hull to, like, some of these machines are huge,
Oh yeah,
down to, like, maybe the arm of a robotic, device of some sort, but
yeah.
when it comes to welding, you're always going to need somebody that can kind of spider monkey their way into something crazy because a pipe is burst way back in
Yeah.
the utility room or whatever. Like welding, I think is kind of one of those like I'd say it's going to be safe. It's going to be around for a while because of what it allows.
That there is more automated welding going on nowadays,
Mm,
but the same, I've heard this conversation with machining is like, oh, you don't need to learn manual, like everything's going to be CNC, and I disagree with that
mm,
statement because there will always be one-off repairs. There will
hmm.
always be like, I have this 80-year-old hydraulic cylinder, no one makes parts for it anymore. I
Yeah,
need these parts now,
yeah,
and you got to be able to reverse engineer what the part was and then quickly make it. And CNCs can do that, but there's a time and a place where it's like, if you just need a quick one off and it's not like crazy contours and formed surfaces, it's just like a ring or a blocky part with threads and reliefs in certain spots, like, and that's what a lot of it is. There will always be a need for manual machinists and welders.
yeah,
So I'm not telling people don't learn CNC,
sure,
but definitely don't skip over the manual machines, because all the
yeah,
really good CNC machinists I know, they got their start on manual machines and learned what the cutting tool is supposed to sound like, what how the machine is going to be vibrating in this type of
mm,
cut, or if you're going to get shattered doing this operation. I've met
yeah.
other engineers and machinists where they've done nothing but started pushing buttons, and
Mm.
ooh, it can get fun sometimes.
A little dicey, yeah, so I'm glad you brought that up, the institution where I work is also, they have a really amazing apprenticeship program,
Mhm.
and they start everybody it doesn't matter what experience you came in with, they
Mhm.
start everybody on these gorgeous, like, 1940s through 60s, like, chromed out, like, they look like they should be cars on the road, they're so pretty,
Yep.
machines that are, like you said, manual, so that,
Yep.
"Oh, this is what it feels like to try to drill through this kind of alloy," and an alloy is a blend of different types of metals, and
Yep.
that can be different percentages.
Yeah, all the different alloys, especially like your high carbon tool steels, learning like, oh,
Mhm.
or like if you're drilling chromoly steel, it's one of those like, yeah, I need to make sure that this tool is constantly cool and lubricated.
Right.
Otherwise, my material is going to work harden, dull my bit, and then things get really bad.
Right. It's gonna be a little different than drilling through, like, the aluminum of a soda can, like, you can't treat all metals the same. Let's back up a little bit. Let's talk about the basics, basics, basics. Let's talk about you talked about MIG. Let's talk about TIG welding and some of the other kinds of, like, the mainstream welding, and then let's
Yeah.
talk about, like, the difference between, like, a mill and a lathe, and that way
Mhm.
we can kind of transition into more, like, what a CNC does versus
Yeah.
having hands-on.
Okay, so the different types of welding. The first type of welding was oxyacetylene welding, and that's kind of fallen out of favor. There's some niche people that do it. I know there's some motorcycle guys that do it for like fuel
Welding
tanks and frames.
hipsters.
Yeah, and I actually haven't done any oxyacetylene welding. I just haven't had a desire to. I do use oxy torches all the time, for like silver soldering and brazing, or torch cutting. But then from there, was stick welding, where it was a metal rod dipped in flux, and the electrode burns away as you weld, and it deposits itself into your weld joint. Then there's TIG welding, which is tungsten inert gas welding, where you have a tungsten electrode, which is where your arc starts from, and it goes to the material, and you create a puddle of liquid metal with that arc, and that there's shielding gas flowing all around that metal, so keeping oxygen out of that liquid metal is of utmost importance, especially once you start getting into some of the more exotic alloys. And then as that puddle is going, you either will then fuse the two base metals together in fusion autogenous welding, or you will add filler rod and use that filler rod to join your two pieces of metal together.
Yeah.
That's my favorite type of welding, because that's the one that requires the most skill and is your as a welder, it's your signature.
Yeah.
And I have a few little cheap tricks I like doing. I do a lot of autogenous fusion welding because I deal with a lot of like ultra high vacuum equipment, and for the most part, you want your fit up to be perfect. So that's where having a machining skill, being able to make that joint and make it so there is no gap. It is just metal to metal, perfect seam running down the middle, and then my weld can come over. And there's little tricks where it's like knowing what the amperage needs to be at, what your tungsten size, your gas flow. If you do pulse, for anyone that's listening that likes doing autogenous welding, 2 pulses a second, 60% background, 60% on time. It will give you that perfect stack of dimes. Look, that's my cheat code. That's my one little nugget of wisdom I'm going to throw out to any welder listening to
you
this.
heard it here first, guys.
two pulses a second will give you a perfect beat. So just throwing that out there for people.
Nice. All right. Hell yeah. Yeah, I wanted to talk about that. It's amazing to hear you throw out all this jargon, all these terms, because for the first chunk of this first season of Blue Collar White Coat, I've been talking to a lot of my friends who are scientific background, right? And I have to like slow them down. I'm like, whoa, it's too much on the big words side, like give us some explanations. And here's a profession that doesn't necessarily require a 4-year degree. Requires training, requires trade school, requires certificates. I know is a huge thing for welders.
What's funny is I don't have any of those.
Oh, really?
I don't have any. I don't have any certificates. Like, I do know how to do all those types of welding. I know, like, I've done sanitary welding. Whenever I've done anything that's pressure related, I am very explicit. Like, I am not a certified welder in this. Like, you guys are taking on this liability. I've done these welds for companies, and then they'll send the stuff off to get inspected and X-rayed, and it comes back fine. So it's one of those, like, I'm just very upfront, and it's like, I cannot be held liable for this. But here's so you guys know, like, like I said, they sent the materials off, things X-rayed, came back perfect, and stuff's in service. So and I never went to trade school. I don't have a 4-year degree in this, just a fire technology degree.
And yet here you are throwing out as many big words as all of the science people that I've interviewed. And like, that's such a perfect snapshot of what I want this show to be, is to show that, like, a lot of times people, when they hear what I do, they're like, oh, you're a science communications person. That means you dumb it down for people like me. And it's like, no, nobody is, you know what I mean? Like, we need to stop looking at each other at like, you're smarter than me, or or this person's dumber than me. Like, no, everybody is smart at different stuff, and the more we like appreciate that and work together, we can get so much more done, instead of like,
I've met some really dense PhDs where it's like their field of interest, they are the
laser
expert, and they
focused.
know it. But then you throw them in a machine shop, they're like, oh, you can just do this, right? I'm like, that is, I can do the impossible. Miracles might take a little longer.
I like that. That needs to go on a t-shirt for sure. Wow, that's amazing. So yeah, I just wanted to kind of cover some of let's talk about like the mill and the lathe. That's everything, like you said, from your garage shop to these huge like NASA machine shops. Like it's almost like a hammer and a wrench. Like, that is a standard tool for
pretty much. So a lathe they're both spinning machines with usually an X, Y, and Z axis. So with a lathe, it holds onto your material and spins the material, and your cutting tool is stationary. And your cutting
Mm.
tool cuts material off of the parent piece. And yeah, I always say machining, you start with this block of material, and your part is buried in that material. And you have to remove enough material. Or I think it was Michelangelo was asked, God, I think it was after he did David. Someone had asked him, and this may be just internet lore, but the way I'd heard it was someone had asked Michelangelo, like, how did you know how to carve uh, the statue of David? And he said, well, I
Right.
just removed all the marble that wasn't David.
Yeah.
Uh, so
Yeah.
so with a lathe, your material is spinning and your
Hmm.
cutting tool is stationary, and it's
Hmm.
usually working in a horizontal. You're usually just doing the x-axis and the z-axis.
I feel like a
Um,
good example a lot of people have probably seen is woodworking. Like if you're making the leg of a table, you've probably seen on TikTok or whatever woodworking,
yep.
version of this. But in
Yeah.
metal, it's the same idea. But is there
J-
coolant involved with that to keep sparks down and whatnot?
yeah, yes and no. Depends on the material. Depends on how heavy an operation I'm doing. Like if
Mm,
I'm hogging material, I'll spray some cutting fluid on there. If it's just like I'm just taking a tiny little skim cut, and it just depends.
hmm,
Usually, a good rule of thumb is just coolant is or like some sort of cutting fluid is usually good.
hmm,
That just helps keep your heat down, keeps everything happy. Your cutting tool sharp and whatnot. So then there's a milling machine, which usually I'm going to use a Bridgeport style mill as the example. That's the most ubiquitous.
hmm,
They're kind of like a glorified drill press in a sense, where you have your cutting tool is in the vertical orientation and the cutting tool is spinning. You then have your
hmm,
work underneath it, and the work can move in the X and Y uh, the X and Y mean and in the Z, and your cutting tool can also come down in Z. So you're able to do work at multiple depths, remove multiple pieces. You can put on a rotary table to make your material rotate and do like a nice radius on something. There's different types of cutting tools depending on the operation you're doing. But
And there's
for the
like
most
different
part,
sizes of these things, right? Like you could
yes,
go from making like a I don't know, like a what's a good
I there's everything from your little tabletop milling machine all the way up to mills the size of my or lathes the size of my house. I'm not
right.
joking. There are vertical turret lathes that have a platform that's 50 foot in diameter, and that whole thing spins.
And that's
And
to make anything from like I don't know, I'm just gonna throw out examples, but like, the a rocket ship, parts of rocket
yep,
ships down to like something the size of like a peppercorn
yeah.
and all out of metal.
Usually on the big machines, you're not doing the itty bitty work, but yeah,
No. Yeah. That's what
uh,
the little ones are for. That's what the tabletop
yeah.
ones are for. Yeah, yeah,
But like
yeah.
so like yeah, making flanges for nuclear reactors. Like you have a reactor that's got a 20-foot diameter ring. You need a machine that can swing that 20-foot ring. Uh,
Wow.
so that they make different machines for all different sizes, and just the sky and your imagination are the limit, basically.
Fortunately, because what I do, I get to go into not just labs, but also things like machine shops and see these massive machines that until this job, I had no idea existed. And then, like,
Yeah,
once you see them, you're like, oh yeah, duh. Like, how else would that get made? Like, that makes sense to see that.
yeah,
And there's so many different variations of them too. Like, I know that there's like 5-axis. Is it
hmm,
mills? And so it literally can like go make a sphere, and
yeah,
cut out chunks of that sphere because it has all these different points where it can shape
yeah.
from. That's so cool. But yeah, so like what talk a little bit about you talked a little bit about your experience as a high school kid and like were you interested at all in sciences or
Once again, I had no idea. I was into wrestling and athletics, and I was a solid B student. Like I was not
yeah.
like the smartest kid in class. I wasn't in the back of the class, but I just had no clue what I wanted to do. I didn't even
Mhm.
know that trade school was an option.
It was squashed for us, like, because we're about the same age. It was not an option, and it was very much the people that were the decision makers when we were youngins were very, I don't know, it felt they looked down their nose at the kids that took shop class, at the kids that, like, that's how I perceived it,
I'd agree with
you
that
know?
sentiment.
And it's not helped with the division that there is in this country right now. And I feel like a huge part of it was our generation getting like shamed away from pursuing trades and pursuing non-degree holding careers. Why? Because college was making people money. That's why. Anyway, that's a different podcast, but
so I ended up going to like 5 different junior colleges. I wrestled at one in the fall and then had to go take fire tech classes at another. I was taking a very stacked course of units. The stuff I needed for my fire tech degree. I was working almost full time, like 20 to 30 hours a week, going to school full time, and I pulled off a 4.0. I was like, I don't know how that happened.
Right.
But it worked. So
hey. As a solid C student, I can relate.
And so the Wildland firefighting was a ton of fun. And
that sounds crazy.
I always joked with people that it was like every little boy's fantasy. It's fire and chainsaws.
And camping. What?
I got paid to camp. Like the 2007 fire season was insane for me because in a 6-month period, I had just shy of 1,500 hours of overtime.
Wow.
So if you took my overtime and turned that into 40-hour work weeks, I worked an extra 9.5 months in a 6-month period.
Oh my God.
On top of the normal 40-hour work weeks. So that fire season was a rough season.
So what is it like having done wildland firefighting professionally and seeing the news and the coverage that these or not coverage that these fires are getting right now?
There are a lot of factors that have led up to where we're at now. You got climate change, which isn't helping, but then you have the fire suppression tactics of the last 100 years where everything used to be considered a 24-hour fire, where we're going to get this fire out in 24 hours. And the reason for that was because at the time, forests were considered a resource where it's like we can sell these timber stands. And if a fire burns through this timber stand, we're not going to get the revenue. So that's why everything was considered a 24-hour fire, even though what I consider a healthy forest, the way I've always heard described is a healthy forest is one you can ride a horse through and not hit a single branch. Where fire is a natural part of the ecosystem that goes through, burns up all the dead and down. Occasionally will burn a small stand of trees, but just kind of runs through, gets all the dead and down and allows for new growth.
Right.
That has been prevented, and now there are areas that just haven't burned in 80, 100 years, and you get this fuel loading of the live dead to down ratios are just insane, and then you get these climate these climate imbalances where the winds, the heat, everything, and it's going to take a lot more controlled burns, I think, before we can kind of get a handle on it. But at the same time, people don't want to have controlled burns. And I think the fire down in the Grand Canyon this last year that burned up a famous lodge, I believe that was a controlled burn that got out of control. So
it's crazy because for so long, where's my tattoo? This guy here, Smokey the Bear, right? Was fires are bad, fires are bad, fires are bad. Only you could prevent. And now it's like having, as a communications person, I'm like, man, that is quite a challenge to shift the cultural understanding and attitude towards no, controlled burns are needed. And hey, it's like the indigenous people kind of knew what they were talking about. Who knew? Podcast on that. But to go back to like skills and just kind of like getting getting, I don't know, what's the word? Like, I feel like my career has very much been vibes based. And I feel like you and
Yeah.
I have that in common. And so, you know, while you're a wildland firefighter, like obviously you're out there, you're digging, you're doing the like
Hmm.
actual hands-on boots on the ground stuff, but
Hmm.
you're also working on the machinery, right? The heavy equipment. Is that kind of where you started?
Well, so on the fire crew, we didn't really have heavy equipment. The only stuff
Mm,
we'd basically be cutting a trail next to the fire. And the idea is you have your fire triangle, fire tetrahedron, whatever you want to, however you want to call it, where it's fuel, heat, and oxygen, chemical chain reaction. You need to remove one of the legs of that triangle, or one of the points of that triangle, to break the fire cycle. So our whole point was we would be cutting along next to the fire and removing fuel from the fire and then scraping it down to bare mineral earth. So the fire would burn up to that edge, or we'd be cutting on the edge of the fire and removing fuel. The fire goes out that way. And the idea is that, like, you say your fire starts here at the bottom of the hill and burns up. You get a crew going on either side, and eventually they come around and pinch it off. And that's the idea with wildland fire, is that you remove the fuel from the fire and put it out that way. So we didn't really have heavy equipment. There are bulldozers that, depending on the fire and location, they can get access, and they are basically cutting a big trail. Where
yeah,
we're putting in
yeah.
like anywhere between a 1 to 3 foot trail, they're putting
With
in a 10 foot.
shovels and
Yeah,
elbow grease. Yeah.
yeah, they're putting in a minimum 10 foot wide trail
Right.
uh, instantly, but they
Yeah.
can't go everywhere. So
Yeah.
like they
Yeah.
can't go on really steep terrain. They can't go in sensitive habitats. So
Yeah. No fire
uh,
roads, no access.
yeah, exactly. So with heavy equipment, the equipment that we basically had was chainsaws. So you got your two-stroke, your bar oil, your tools for sharpening and doing basic engine maintenance
Sure.
if you need to pull a spark plug or something. But for the most part, and then occasionally we might have a portable water pump. So I mean, I got my commercial driver's license when I worked for them because I could drive a water tender, drive a crew buggy, uh, get dump truck vehicles with air brakes, things like that. But not a lot of heavy equipment for a wildland firefighter unless you specialize with. So
Okay.
yeah, and that was kind of how I got my start. Was I got to do a couple stints with the bulldozers, and I had a ton of fun with it. And they were really instrumental in teaching me the basics
Yeah.
of building stuff with my hands. And they're like, hey, we need to build some radio holders for the dozer. Here's some box tube and plate, figure it out. And it's like, okay. They're
That's
like, oh,
cool.
okay, you made that. How are we going to mount it? Where are you going to put the tabs? How are you going to make it? Where is it going to mount on the machine? Like, or if we needed to do maintenance on one of the semi trucks, definitely had. There was one day in particular I was working on the air brakes for one of the semis, and one of the very few times I've actually thrown a tool.
Oh,
I go to tighten these fittings, and I didn't at the time. I didn't know. I thought like, oh, it's a suede schlock fitting. I just tighten it with a wrench. I go to tighten it with a wrench. I didn't have a backer wrench, and it just sheared right off.
oh
And it was
no.
like, oh, man, okay. So I let the operator know, like, hey, we need to go to Napa and get a new airlock fitting. And he's like, okay, let's like make sure you use a backer wrench when you do it next time. We bought some extra fittings just in case.
Sure. Sure.
Replacing the fitting, I got the backer wrench. I'm trying to use opposing pressure, and then the part sheared even further back. And
Get.
that was when I threw a wrench down the yard. I was pretty pissed on that one, but it was one of those. He's like, "Oh, now you know."
Yeah, 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 exactly. Learning the hard way, but here we are. That's crazy. Oh my gosh.
Yeah,
I guess I didn't think about like, you know, creating a radio holder. That makes so much sense. It's like this is
yeah,
pretty low stakes. Let you kind of noodle with it and figure it out. But also at the same time, it's like what not just like what's the shape going to be and how like but also like if
yep,
your welds aren't good and your tabs aren't good, like the first time that bulldozer jostles it
yeah,
the right way, it could just fall off. Like you really have to
yeah.
kind of figure it out.
So,
Interesting.
so yeah, that was fun, and so on the hand crew when we weren't on a fire, we'd be doing road maintenance. We'd be like clearing brush off roads, making fire access for places. with the dozers, we would do occasional fuel breaks and fire road maintenance, like
Mm.
grading and whatnot. But then when we weren't on a fire, we were just kind of around camp, and we'd do our morning routines. We would make sure everything, like fire everything up, make sure everything's running properly. But then I would have time to figure stuff out. And we had a workshop with like a drill press and a MIG welder and this ancient old TIG welder and oxyacetylene machine or oxyacetylene setup. And I I would just kind of get to play in the shop and just figure stuff out. And they would be like, "Hey, we need a rack for holding this material," or the fire crew called, they need a rack for holding all the weed. And I would have to figure out and make these things. And that was where I really first started getting this like, "Oh, this is fun to make stuff with my hands." Like, but like I said earlier about like starting
Yeah.
with that block and uncovering your part out of there is something really gratifying. And
Hmm.
until someone really works with their hands and does that, like I don't really know how else to describe it, as like when you start with nothing and then end with something. It is a
Yeah.
really gratifying feeling.
I feel like it's a good metaphor as well for like the kind of path my career has certainly taken, where it's like I didn't know what I wanted to do when I was 18, and I mean I got to do some really amazing things that people dream about doing. Super lucky that, well, I wasn't lucky. I worked really hard, but but even then, like I was like, this is fun, but like, what next? You know, like where is this going? And I feel like that block of material and whittling out, like, this isn't really for me. Like,
Yeah,
this is fun, but me, what else could I create? Like, what else could it? That's like a really good metaphor for like sometimes you don't start with that clear picture of exactly what you want to do. Sometimes you
yeah,
start with a really huge scope of what you're interested in, and then whittle down like to what you want to do and what your purpose might be from what you're not really into.
well, there's a good saying with that, where it's form follows function. So when you're making something, how you design it is what's going to be its intended use. How is it going to be used? Who are the people that are going to be using this? Because that is a big one, especially working at the skateboard manufacturer. We had a lot of just temp employees who did not know stuff, and the one tool they would have in their hand would be a hammer. So every problem looks like a nail. So I now need to,
Mm.
now whatever I make needs to be able to survive that hammer, because they're going to be beating on it like it owes them money. So
I think that's one thing that engineers do really well is, and that's why a lot of folks go into engineering, is because they want to help. They want to make an earthquake proof bridge. They want to make things that are easier for folks to use, or are more accessible for folks that aren't walking around. They're in a wheelchair or
yeah,
something like that. So I think if more people approached like all the problems with like how is someone actually going to use this, or how can they not use this, how will they,
yeah.
I think that's really neat. What a cool perspective.
And that's one of the things. Like, so in my current job, someone will come in with to my shop and be like, "Hey, I have an idea for this chemical reactor," and I have trust issues. So like if someone gives me a drawing, I don't
Yeah.
I will question it. I'll be like,
Hmm.
"Okay, what's the material going to?
Sure.
How hot are you going to be getting this to? Oh, you're getting it up to like 1200 C and you're having this out of aluminum? That's not going to work. The aluminum is just going to melt away. We got to
Yep.
start looking at like some really high temp alloys if you want to get it to that temperature and pressure." Um, or it's like, oh, it's just, or if someone comes in and says like, "I need this thing to be perfect to the smallest micron," it's like, what's it doing? Oh, it's just holding the speaker. Then it doesn't need that. Like, so that's where I start asking questions, and through my experience with different engineers and being able to ask the right questions of
Right.
who's going to be using this, how is it going to be used, what are the environmental factors, like, oh, you want this thing made out of steel, but it's going to be next to the ocean. Might not be the best idea. That thing's going to rust away in a week. So
Yeah. Yeah.
it's just being able to ask the right questions and lead people to the right answers, I think is definitely a skill that gets developed over time that is very
Yeah.
beneficial to have. So
I really like that because that's something that I'm definitely trying to learn to do more. Like being someone that's like 40 now and transitioning away from the like person that needs all the learning and all. Not that you can
yeah.
never, not that you're ever done learning, but like, and now like there's these people that are younger than me and they're like born in the 2000s and stuff, and I'm like, oh no. But like that's something that I am. Also, as a big sister, so I'm just like inherently bossy and like doling out unsolicited advice like it's my job, but asking questions, because I like I said I'm really interested to talk to people on this podcast about this like age old like engineer versus skilled trades person. Like no matter who I talk to, it is the same thing. And asking questions though, I feel like instead of being like, this is wrong, this ain't gonna work, like that's not gonna win you any friends. Like
When I was at the blacksmith shop,
hmm.
I ended up getting the nickname the Storm Crow because I was always going to be like, hey guys, there's going to be an issue here. Like, this isn't going to fit or this isn't going to work. And there's a time and a place, and there's ways to ask that and say that. I've definitely learned those. But then when I was at the clean coal company, I was treated basically like, oh, you're just a dumb welder. You don't know what you're talking about. Do you want to be the engineer? Then let me do my job. And it's like, dude,
Oh
I'm trying to. It's like
no.
we're all on the same team. We
Right.
all have the same goal in common. And I remember overhearing one conversation saying that I was just team negative, and it was like, no, I want to help them, but when they ask for something that is physically impossible, or they give me a time frame, it's like, no, like and that's not me being negative. That's just me being realistic here. So, but then when I got the job at the skateboard manufacturer, the engineers I worked with, they were amazing. Like I really enjoyed working with them because they were okay with me being like, hey, like this is cool and all, but could we make this a little easier for me to fabricate? It's like, oh yeah, yeah, if you want to do it that way, go for it. I heard this on a welding podcast ages ago, and I ended up using it in my interview at the skateboard manufacturer. The question that's asked in the interview is, tell us something negative about yourself. And you never want to say something like, oh, I'm a shithead to work with. Oh, sorry, I got a short fuse. You don't want to say that. You want to answer every question in a positive.
Sure.
And so they asked me, tell us something like you need to improve on, or that would be considered a negative about you. And I said, well, I am exceptionally lazy. And they both kind of like cocked their head like, okay, where's he going with this? I'm like, you give me the hardest problem you have, and I will find the easiest way to do it. And the older engineer goes to the younger one, smacks him in the shoulders. He said, see, that's what I'm talking about. That's what we need. Like, so it was one of those like, and I agree with that. It's like, I have a hard problem. I don't want to sit there banging my head against the wall for a week trying to figure this out. I want to get it done as easily as possible because it's going to be a hard problem. So that is another way I try to approach
Yeah.
problem solving and thinking about stuff.
No, I love that. I wonder if there's something to be said about like, because I never until this conversation considered the fact that there would be engineers working at a skateboard factory, or so maybe it's just the nature. Like they're probably going to be more laid back than the engineers that are like designing bridges and buildings and things
That
like
was
that.
one of the things we would always say is, it's like, it's not going to Mars. We're building skateboard parts. Let's have fun. On our breaks, we all made fun skateboards. I have a dozen fun skateboards. We would go and skate around and have fun. I really enjoyed the team I worked with. We just had fun.
Yeah.
Because yeah, it's skateboard parts. No one's
Low
life is on the
stakes.
line. This job at this research institution came up, and it was like, oh, I get a pension and I get to work by myself. Hmm. So it's like, I'm like, I'd be a fool if I didn't even apply.
Sure.
When I had the interview went well enough, but I was fully expecting to get a response of, thanks, but no thanks. Come back when you get some more experience. Like, come back
Yeah,
when you know when you know how to program a CNC. And it
right.
was like I was fully expecting that. 2 weeks went by, hadn't heard anything, and I was out camping, and I get a voicemail, and it's like, "Hey, just letting you know you got the job, so like call us back, please." And it's like, oh shit, I got to put my money where my mouth is now. Like, oh crap. Like I said, imposter syndrome
Mm,
kicked in hard on that job.
mm.
I definitely had times where it was like, I hope I can do this. Uh, but one of the fun things was so taking a step back, starting with the blacksmith shop, and I kind of view that as like the R&D, my start in research and development. So I where we viewed things like no one's ever done this. Like, we're
Yeah.
making this custom, unique, uh, whatever. We got to figure it out. So, and like we'd try things sometimes, like, oh, that looks like garbage. Cut it out. Like, let's start over again. So,
Yeah.
and then working at the coal company where it's like, okay, we're running experiments, and we have this big hopper mixer thing, and we're not getting the right results. What can we change? We've been doing our process this way. It's not working. We need to add a new step in here. How are we going to incorporate that? Where are you going to put it? They would design things, this giant Rube Goldberg machine of how everything flows through. And then I would go like, okay, cool. How are we going to run maintenance on that extruder? That extruder is now 15 feet in the air with no platform for anyone to work on it. And the barrel that we have to pull after every run, I've only been here 2 weeks, but I know that whenever we run the extruder, when we're done, we got to pull the barrel, and that barrel weighs 300 pounds. I'm using a forklift to do it. How are we going to do that when it's 15 feet in the air and there's no work platform? Oh, what can you figure out? Okay, I'll weld up the platform. Like, it's things like that would happen. And then at the skateboard manufacturer, like, do variations on things. We're making it was a big team effort working with the CNC machinist. My setup, I was doing a lot of welding, and we're basing this coating machine off this pneumatic rotary indexer. And we designed this whole thing around this indexer. And we would have it spray these parts, go through a drying tunnel, and then get kicked off. Well, we've got the design, we're making the parts, we're doing all this, and I had to refurbish the indexer. The air cylinder was no good, so I had to replace it and modify this new cylinder to fit the old machine. So I'm like, I should test this. And I hook the air up to it, and I see the machine activate the indexer, and I've seen the drawings. So I go to the lead engineer. I'm like, hey, what direction is this indexer supposed to be turning?
Oh no.
It's like, oh, it's supposed to go counterclockwise. It goes clockwise.
Oh no.
Oh, and of course, it's end of the day on a Friday when we're getting ready to
Right.
test it. I'm like, we got to figure out some new stuff.
Oh no! Oh god, I feel like I've
So,
heard so many stories like this where it's like, just whether it's brackets or whatever, like, okay, these are all left facing and it's supposed to be right, like your
yep.
drawing was backwards or whatever, and then they're mad because, well, why did you make the thing that I drew? Well, because you drew it. Like,
Yeah. So the engineer I worked with, he had another saying of, make your part to the print. You're going to have to file it to fit. Make to print, file to fit. Not everything will always go as planned, but being able to work in that R&D mindset. I am not the fastest machinist. I'm not a production machinist. I am an R&D machinist. I need to do it right the first time, because sometimes I'm given a piece of exotic metal that only exists in this sample. And if I mess up that material, it's like months of time have gone away from like hundreds of man hours of work is now scrapped. So it's like I need to make sure that I do it right the first time. So I'm going to take my time, make sure my setup is right, make sure that the machine has good tools and it, good coolant, that I'm doing everything properly. And it may turn out that, oh, that doesn't work, or oh, it is scrapped, we need it to be this size instead, or this shape instead. And that's fine. Like I've learned not to like if something comes back that's not my fault, it's like, okay, this is part of R&D. We are pushing the limits of our human knowledge, and we're going to get it wrong sometimes. And I really enjoy that. Just the fact that we're kind of on that cutting edge, being able to make things that no one's made before, or test some unique element in a way that's not been tested or mixed before. The other stuff I like doing, where someone will have a piece of research equipment from like the 50s or 60s, and
Yeah, this happens
hey,
a lot. This happens a lot.
this machine that used to do this is broken.
And the guy that knew how to fix it retired 10 years ago.
Yeah, here are the pieces. Can you put it back together? And it's like, okay, let's get it. Like I like those
Yeah.
jobs. The other types of jobs I like, because I feel like a god when you do it. I call them the get her out jobs, where it's like I have this reactor vessel, and I've sheared off three of the four screws, and they're stuck in here, and I am dead in the water unless you can get these screws out for me.
Oh
And
my
that's one thing.
gosh.
And that's one thing I've gotten really good at, are what I call the get her out jobs. Because
Doing that
it,
without throwing the wrench this time. Like that you're
yes,
healing the
yes,
trauma of that first
yes.
experience.
So
Yeah, yeah. Well, so we talked a little bit about the experience of being in high school and not knowing what you want to do and
Mhm.
feeling like you have to go to college. And now I think we're in a really cool time where that is not the case anymore. Like you said,
Uh-huh.
YouTube University offers so much. LinkedIn too.
Yes.
Like there's so much information out there. But talk a little bit about being established and switching gears and like deciding I'm going to go from skateboard manufacturing to this major research institution,
Mhm.
or even wildland
Well,
firefighting,
well,
to like talk about that.
so the big one that definitely, it took some soul searching, was having to make that transition away from wildland firefighting and firefighting in general. Because I had a fire
That
degree, I had my EMT license, I had gone through a fire academy. Like I had everything I had done up to that point was for to become a firefighter. When I saw that ship sail, it was like, okay, this is kind of scary. Like I will never be the guy pushing the green button doing a 10,000 of the same part. I think it was more trying to fill that void of what is something I can do where every day is going to be different. It's going to be intellectually stimulating, and it's going to allow me secure, making that transition away from firefighting, where this is a solid, steady union pension job. But when I saw that that was no longer an option, it was like, okay, I guess we're going to see where this welding and fabrication thing goes. So after like a year and a half, it was like, okay, now welding will be in my career probably forever. And that was when I made the decision to buy what I considered the best hood on the market. And it's
yeah.
still my favorite hood. I call it my money maker. I've made over $1 million with that hood, just with my career
And this
over
is
the.
the face shield that
Yes, this is
everyone
the
is
face shield.
okay.
I sent you the picture of it. I think it's like my
Yeah.
profile picture. And if that's a piece of advice I could give to someone, is just like, go around, visit different shops, see how people do things differently. Like I'd stop by woodworking shops, I would stop by other shops and just get little tours and chat with them about making it. And if you start asking someone like, so what do you do? Like they want to tell you. Like everyone's proud of what they're making. So like they will tell you about themselves. Um so anyhow, like I bought this, what I considered a top of the line hood, because it's like I need to take care of my eyes. Because my eyes are, that's my career right there. Overall, safety glasses are the bare minimum. Like, take care of your eyes. I plan to retire with both eyes and all 10 fingers.
Yeah, for sure. So like would you say that's a good metaphor for, invest in yourself? And if you're going to make a mid-career jump, first of all, people do it all the time. Don't be afraid of taking that jump, but also be calculated about it. And once even if you have to take a year or two to just figure out what your next move is, once you figure it out, like put the money down, invest in yourself, whether it's a certificate or a degree or a really good piece of equipment.
That weekend training course, or like taking the time and yeah, like you said, investing in yourself.
Yeah, showing people that you're serious about it. Like, look, I may not have the years on my resume in this field, but I'm
Mhm.
serious about this.
And I think that's one of the things that help. So at the blacksmith shop, when I first asked them, like, "Hey, you guys need a hand?" and they kind of blew me off and was like, come back in a month.
Yeah.
And I talked to him, was like, so why did you do that? And he's like, well, we don't want to hire someone that's not serious. Like, we
Yeah.
don't want someone who's just looking for a job. It's like, you want someone who is like, they're going to actually invest the time to get good at it and not just view it as a just straight 9 to 5. And the welding class that I teach, it's not even a class. It's like I volunteer on my lunch sometimes, just it be a couple students come in. I kind of limit it to 2 at a time. It's the people that come to me and like, hey, I'm really interested in welding, and I've been told that like you're really good and you'll teach people.
Where are the students coming from? Are they just like anywhere in the university?
The people I've taught have primarily been engineers,
Oh,
uh,
cool.
just because there's no welding program, and that's one thing I would love to see is more welding programs, more trade schools with that focus, not and focus not in just a production mindset, like trying to get you the certs so you can do pipeline welding. Having more accessible trade school options, I think, would be really
Sure.
beneficial for a lot of people.
And I wonder if those engineering students that you've helped on your lunch break a few times 10 years down the road are not the ones going, what do you mean? Just do the drawing, right? They're probably, they have a little bit more of an appreciation of the
Yeah,
metals and how they behave and that kind of thing. That's
yeah.
interesting. That could be a whole thread right there. We're almost out of time, but can you give us a quick rundown of the kind of research your work supports where you are now?
For the most part, it's a bit of everything. I work with different departments, physics, engineers, materials, chemistry, chemical engineering, art departments. Like I do everything.
That's so cool.
It's fun, and that's where I say like every day is something different. And sometimes you do get those jobs where it's like your heart sinks a little, like, oh, this damn thing is back. Okay, like, oh, you guys put channel locks on it to try to open it. Great, thank you, thank you. Not using the right size wrench this time, but then you get those real unique jobs where I got to help one guy on for his PhD. He was working on liquid batteries,
Oh,
and
cool.
helped him design the cells that these liquid batteries would work in. And he had first tried them with glass. Then we did a simple one with out of a large piece of Teflon. And then one of the more like first jobs I had with him, where he's like, okay, I need these channels to be this size, but I need everything to interlock with this size gaps and these depths and these things. Like, and he's like, I need you to design. Okay, let's get it done. And so I make these parts, and he ended up getting his PhD, and he got published in a scientific journal and put me as a co-author on that. So I was like,
Hey.
and I thought it was funny. I got mislabeled as like Dr. Kyle. I was like, nah, no, 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 no. I am not. Uh,
A doctor in the
so
school of life.
no, it's the Doctor of Hard Knocks. I don't know. Like,
That's so cool though. And I guess like
yeah,
that's like one of the last questions I had is, for people who that's largely who I want to reach with this podcast. People who are interested in STEM, folks that like me that were told like, oh well, you can't be a marine biologist because you're not good at math. What would you say like 20 years ago?
uh-huh.
Could you have ever imagined doing what you're doing now?
No.
Like what would you say to someone who thinks that there's no place for them in STEM?
What you think you may be doing now will not be what you're doing 20 years from now. Had you told me that I would have this job, I'd call you a goddamn liar. Like there's no way I would have envisioned me having this job 20 years ago. Like it wasn't even a thought. Like I said, I fully thought I was going to be a firefighter. Like that was the goal. And then it's getting hit with this curveball of like, okay, well, now I need to pivot. What's this going to look like? And kind of going with the flow, but at the same time when you go with the flow, you can still direct like what side of the river you're going to be on. Keep your options open, don't stop learning, and just keep an open mind about what's out there, because yeah, I didn't know that a skateboard manufacturer would need an R&D welder and machinist. And going back to what you were saying about like, I didn't know that they would have engineers for that. It's like, if you think about everything that we use in a day-to-day life, a paper cup or a plastic Dixie cup, there's an engineer that's first designed the cup, then designed the mold, then you had a machinist have to make the mold, and holding those tolerances and making those parts, and then you have the operator that's then making those in a production. So there's a lot that goes into what we use on the day to day that can still be really fulfilling and really unique and a lot of fun. So
Yeah, no, I love that. And that kind of leads into the last question, which is, being myself on the STEM side of things,
Mhm.
things are pretty scary right now in terms
Yeah,
of like budget cuts for research and budget
yeah,
cuts for things like, wildland firefighting
yep.
and NASA even. And so it's it's hard to not get bogged down by that. But, you're on the academic side of things. You're seeing the engineers that are up and coming. You're seeing the scientists that are up and coming. So maybe you have unique insight to this, but what are you actually like hopeful for or optimistic about in the future of STEM?
That is a loaded question. That I mean, the cuts to grant funding are a big one. One of the professors I've worked with, she lost $1.2 million in grant funding due to DEI language that was required to be in her grant proposal when she applied for it.
Mm,
So she's had to reapply. I think she's gotten it back, but like 1.2 million just disappeared. So this comes back to the pivot. Like, okay, well, what are we gonna do?
hmm
Um, to me, like things change. Things will always change. People come, people go. People are gonna have to be flexible and stay curious and ask questions. Um, yeah, I wish I was a little more full of hope. Like I said, I have the nickname
Sure.
Storm Crow with stuff. Um, there's light and there's shadow. If we can all take care of each other, I think mutual aid is going to be one of those big things that help gets us through everything. Yeah, it's a rough one right now.
And like what you just said, Dixie Cups, like there's always going to be a need for the folks that put this stuff together that we rely on every day.
Yeah,
And even if you're not working at NASA or a research institution at a major university,
yeah,
there's still STEM in everything. So if that's,
yeah,
if you're the listener that's still, wants to do the NASA job or wants to work for national parks or forestry or something like that, it doesn't mean give up. It means do what Kyle has done and find the skills that are gonna be useful when those jobs come back around,
yeah,
because that's how I'm gonna get through this, is
yeah,
believing that they'll come back around. So,
yeah,
yeah, great.
yeah,
All right, well, this has been awesome.
yeah.
Truly, like, yeah, we could have you back for like 3 more episodes, I think, just on all of the different lives that you've lived. But it's also been really validating just to like talk to another person that's like almost exactly my age, that like had the dream job and had to pivot away from the dream job and did a bunch of crazy stuff in between, and is doing a job now where you have to kind of pinch yourself on the daily. So
So yeah, I'm insanely happy. I plan on doing 20 years, and then once I can retire, yeah, I'm not gonna go retire, but I will always be making stuff. Like I said, I have a full machine shop here at home. I do little side projects. I'm into astronomy. I've built telescopes. I just enjoy making stuff. So
that's amazing. Thank you, Kyle. This has been so cool. Like, once again, our generation proving strangers on the internet aren't always a bad thing. So thank you so much for joining us on Blue Collar White Coat.
yeah, no problem. Have a good one.
Wasn't that awesome? I hope Kyle's story gave you a fresh appreciation for the skilled trades and a whole lot of inspiration to take on something new, even if it scares you. You also got a glimpse of, like I said, what's coming in season 2. And look, I'm the one making it and I haven't even really started yet, but I am so excited and I hope that you are too. Next week's episode is our season 1 finale. Oh, it's wild to think about, and I'm really proud of myself for making this far. But anyway, I'll be talking with a good friend of mine, a fellow podcaster who worked for a bit as a mechanic before going to college to become an archivist. And now he works at a university in the UK. And if you don't know this, the UK is super old, so there's a lot of really crazy old parchments and relics that he gets to wear KN95 masks and cotton gloves and go through, which is amazing. But the other great thing about him is he's a historian. So this episode is a crossover of Blue Collar White Coat and his podcast called Seemingly Unrelated, where he takes two seemingly unrelated topics and gives you the history of how they actually really are related. And so in this episode, we're going to dig into the long, surprising, and often overlooked history of how the skilled trades and blue-collar workers have always supported STEM and been critical to pushing scientific progress forward. So it's going to be a perfect bridge into the next chapter of this podcast, and I'm just so excited for you guys to hear how he brings history to life, and especially on this topic of blue collar and skilled trades work in support of science. So definitely tune in, get ready for that. And in the meantime, I'd love to hear what you thought about season 1. We can't get better as a show without your feedback. So send us an email. It's bluecollarwhitecoatpod@gmail.com. Let us know what you liked, what you thought we could use more of, what you didn't like. The more you can give us, the better we can make season 2 for you. Okay, that's it for now. Thank you so much again for listening to Blue Collar White Coat. We'll see you next time for the finale of season 1. And until next time, keep your safety glasses on and your mind open. That was a mess. I am ADHD, but I'm trying to not sound scripted as much.